Okay, so we're going to focus now on naming molecular compounds, and we're going to start by talking about IUPAC. So this is the International Union of Pure and Applied Chemistry. So in the past, there was no standardized method for naming chemicals until the 18th century. So because there was no standardized method of naming chemicals, there was a lot of confusion because the names for chemical compounds varied from country to country and scientist to scientist. So this organization, the IUPAC, is an organization of scientists who set standards in chemistry and how compounds should be named. All right, and they are named according to global guidelines. So the whole world follows these guidelines when they're naming compounds. All right, so we're going to start looking at molecular compounds today. So a molecule, this is the smallest independent unit of a pure substance. It's generally a cluster of atoms that are joined together. All right, so molecular compounds, these are when non-metals combine. It becomes a pure substance called a molecule, or a molecular compound is formed. So recall when we were looking at the periodic table and we saw that staircase. On the right-hand side of the staircase were our non-metals. So these molecular compounds, they can be solid, liquid, or gas at room temperature. They're poor conductors of electricity. They tend to be insulators. The bonding between the atoms is strong, but the attraction between molecules is weak. So therefore, they have relatively low melting and boiling point because the forces between the molecules is weak. Examples of some molecular compounds is sugar. Sugar is C12H22O11. Another example is water, H2O. Another example is carbon dioxide, which is CO2. All right. So molecular compounds, again, they're made from non-metals. It's a non-metal and a non-metal. Very important. Okay, that's how you know if it's a molecule. It's a non-metal plus a non-metal. All right, so remember the staircase in the periodic table. This side here was non-metals. What happened to Caleb? Okay, 1 second. Hey, you guys, I need to go. I'm really loud. Upstairs, downstairs, I don't know. All right. So next, all right, so just to review again, we have the diatomic elements that are made of 2 atoms of the same element, polyatomic molecules, which are made of 3 or more atoms of the same element. So the ones you do need to know, that you need to memorize, so hydrogen, nitrogen, fluorine, oxygen, iodine, chlorine, and bromine, those are the diatomic elements, which I showed here. So that's one method of remembering them. They make this 7 here, and then the hydrogen there as well. So this slide is just again showing elements and their symbols and their formulas. So all elements other than those listed below, they're just represented as shown on the periodic table. So for example, iron is just Fe, its symbol is Fe. These are the diatomic ones I talked about. HNO, FCl, Bri, and then here they have included astatine. And they're diatomic, so that's how they are found. They all have that subscript of 2. Phosphorus is always as P4, and sulfur is always S8. Okay, so meaning there's 8 sulfurs always bonded together. For P4, there's always 4 phosphorus atoms that are bonded together. All right, so now we're going to get to naming the molecular compounds. So the rules are written here. All right, so the first rule is write the entire name of the first element. So let's just think of CO2. Let's pretend we're doing CO2 because it's something we're familiar with. So write the entire name of the first element. So we would just write carbon. Next, change the ending on the name of the second element to "ide." So we know it's oxygen, so that's going to become oxide. And thirdly are these prefixes that we have to use. So the prefixes I've put here on a chart. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 is octa, 9 is nona, and 10 is deca. All right, so we're going to use a prefix to indicate the number of each type of atom in the formula. So carbon, we're just going to leave as carbon. There are 2 oxygens, so we have to put di in front of oxide. So the name of this becomes carbon dioxide. All right, so carbon dioxide we already did. This one is N2O. All right, so there's 2 nitrogens, 1 oxygen. So the name of that would be dinitrogen monoxide. Next, we have N2O3. There's 2 nitrogens and 3 oxygens. So that becomes dinitrogen trioxide. And remember, only the second element changes its ending to "ide." Right here we have 1 nitrogen and 3 fluorines. So that becomes nitrogen trifluoride. So we don't have to put the mono for the first element. You would only use it if it's for the second element. CCl4, that's a carbon and tetrachloride. There's 4 chlorines. Next we have PF5, so 1 phosphorus, so phosphorus, and then pentafluoride. The other thing I want you guys to note is when you're looking at these compounds, they are all molecular compounds, meaning they're all found as nonmetals. So all of these that we looked at here, they're all nonmetals, so the right-hand side of that staircase. All right, next we're going to look at going from the written name to the chemical formula. All right, so first write the symbols for the elements in the same order as they appear in the name, and then we're going to use subscripts to indicate the numbers of each atom. All right, so carbon monoxide, they're done here, but I'll just do them as we go along. So carbon monoxide, so there's carbon, there's oxygen, there's 1 carbon and 1 oxygen, so we just leave it as CO. Carbon tetrachloride, so the elements present are carbon and chlorine. 1 carbon, tetra is 4, so there's 4 chlorines. Silicon dioxide, so silicon and oxide, excuse me. There's 2 of them, 2 oxygens shown as dioxide. And lastly, sulfur dioxide, sulfur is S, oxygen is O, it's dioxide, so there's 2 sulfurs. All right, you also see these states of matter shown. Let's see, yeah, right here, you see a G, L, S, and a G. Those represent the states of matter. So an S is for solid, L is liquid, G is gas. If you see AQ, that means aqueous, meaning it's a solid dissolved in water. Okay, so we have some naming practice here. So we're going to name the following molecular compounds. So what we'll do is you guys can just put the answers in the chat. Okay, so the first one here, it is carbon. Okay, and then our second is oxide. So there's 1 of each, so we would call this carbon monoxide. Okay, so remember to change the ending of the second one to "ide." All right, next one, H2O, that's water. So it has its common name of water. All right, but its chemical name would be dihydrogen. and monoxide. So dihydrogen monoxide. All right, try that third one. All right, so here we have NO2. So there's one nitrogen. We're just going to call that nitrogen. Second, we have two oxygens. So that becomes dioxide. All right, so first name stays the same. Second name, the ending changed to "ide." All right, next we have PCl5. Try that. All right, so PCl5, P is phosphorus, Cl is chlorine. So first name stays the same as on the periodic table. So this is phosphorus. Then we have chlorine. The ending will change to chloride. There's 5 of them. So pentachloride. Don't forget to change the ending to the "ide." Notice all of them. They always have the ending of "ide." How do you know? It's as you get more familiar with compounds, Max, and also they're binary. So binary meaning it will be two compounds. I mean, two elements forming together. So like we saw in the video, these are binary molecular compounds. If there's more than that, then they have common names. So like sugar, right? It has carbon, hydrogen, and oxygen. So if we go back to this worksheet here, counting atoms. So for example, sugar, C6H12O6, it doesn't have a chemical name. You would just call it glucose or sugar, and so on. And some of these are not. Oh, I didn't know I went mute. All I was saying was, if we look at this example here, like sugar, it's C6H12O6. So normally when you have formulas like this, you would give it its common name of like sugar. Another one like table sugar sucrose, C12H22O11, right? So those are the common names. All right, so when we're naming them like this, these are their chemical names, but like water had its common name of water, and sugar and so on. So the ones we're going to be looking at are the binary. So binary meaning two, so two elements. So if you thought this was PCI, it's not binary because then it would be 3. Okay, so that's why it's 2 of them, phosphorus and chlorine. Okay, try the next one. We have nitrogen and hydrogen. Okay, let me just continue. There we go. Never mind. So we have nitrogen, and then we have trihydride. All right, so again, the hydrogen, the ending, it has been changed to "ide." All right, last one, N2H4. Okay, so last one here, there's 2 nitrogens, so dinitrogen. There's 4 hydrogens, 4 is tetra, and we have to change the ending of hydrogen to "ide, so tetrahydride. Okay, so these are just the answers there that we just went over. Next, we are given the names, and we have to come up with the molecular compounds, name of the chemical formula. Say, so sulfur dioxide. So sulfur, there's 1. So S, dioxide, so O. Make sure it's a subscript when you're putting the 2. It's a subscript of O. Next, we have sulfur hexafluoride. So sulfur is S, fluoride is F. and it's hexafluoride, so 6 of those that we saw in the video. Carbon tetrachloride, so we have carbon. Good. Good. All right, so C for carbon. Chloride is Cl, and there's 4, so CCl, 4 like that. Next we have nitrogen triiodide. Okay, so there's 1 nitrogen, and there are 3 iodine. So nitrogen I3. Lastly, we have dinitrogen monoxide. So dinitrogen, so N2O2.